Particle physics is generally a very theoretical thing. And every time we talk about the properties of a particular particle, talk about atoms, talk about subatomic particles, we have only one thought. We really want to see a photograph, a real photograph of this object. And today, first of all, we will look at some very cool photographs of atoms taken with an electron microscope. And secondly, we will determine what is wrong with these photographs. Stay tuned, watch the video until the end, because it will be very interesting. Well, of course, we start by looking at the photographs, taken with an electron microscope. Most likely, you have come across such magnificent images more than once. But unfortunately, this has nothing to do with a photograph of an atom. Even considering that a photograph of an atom itself is quite a fantastic thing, and making it in the way we want is impossible. This here is actually computer modeling, just to get ahead of ourselves, so that such beautiful visualizations are not perceived as something real. Most often, when you talk about a photograph of an atom, and flip through popular science magazines, you see this kind of result, and this result is already significantly more interesting. Here there are some spheres. What are these spheres? And why are they arranged like this? Well, first of all, you see a characteristic orderly arrangement. What does this indicate? It indicates that we are dealing with a crystalline structure, whether it is a metal in a crystalline state or any other body, any other substance. We have an orderly arrangement of atoms. This is precisely what adheres to the very mathematical logic that I often talk about on the channel. And this kind of orderly characteristic arrangement indicates that we have a certain mathematical model that describes what we want to see. But in principle, the way it is arranged here right now is not so important to us because we want to talk about the photograph of the atom itself. So these little spheres, here are the atoms. I believe this is more like transmission electron microscopy. It's interesting and characteristic. Pay attention to these kinds of cutouts. I will show another more detailed photograph a bit later. And these cutouts are the effect of the electron beam on the material structure. When I first learned about this, I was very impressed. After all, essentially, we can now cut a sample directly in the electron microscope. This wasn't possible before. And the first electron microscope I saw worked with foil. And just so you understand, foil is such an unpleasant thing that used to be made with erasers. They would rub this object on the finest polishing abrasives to obtain something suitable for electrons to pass through in order to capture some scattering or attempt to illuminate the whole thing. And by the way, since we mentioned something about transmission electron microscopy, it's useful to know something else as well. Most likely, you have often seen photographs of atoms in this form. Here we see how electron beams diffract on the structure of the sample, returning to that very crystalline structure. And by and large, these are not photographs of an atom in an electron microscope. This object on the right, this scattering, is precisely the scattering of particles on the crystalline structure of the sample being studied. And this is often referred to as an image of an atom in an electron microscope. But this is not an image of an atom in an electron microscope. It's the play of an electron beam on a diffraction grating with its maxima and minima. The next point, you have surely seen such a magnificent work. This is the work of IBM. IBM then created what was almost the first electron microscope and used it to move atoms. And how do atoms move? Atoms are moved either with the help of a mechanical probe or by applying an electric charge. There are slightly different methods involved. If we delve into them, we will go crazy, and it will be boring for us. Therefore, we will not touch on that. But in any case, these are strontium atoms that were moved across a certain field. Again, notice that we see the atom looks like a little ball. A bit later, I will explain why it always looks like a ball and why it's not some strange structure. If you search for the video on YouTube, A Boy and His Atom, you will see such magnificence. This is the very work we are discussing. The guys from IBM made this magnificent image move and dance. Also, when you read popular science articles, you surely come across such magnificent images. And notice, this is already a certain zone. Here, nanometers are indicated, unlike micrometers in the previous photograph. And this structure is, once again, a structure obtained as a result of the accumulation of a certain number of atoms. It is again ordered. Again, it is systematic. This is all that we are discussing about material science. But you have seen this many times before. Let's look at something more interesting. And more interesting is, for example, looking at a photograph of atoms inside nanoparticles. This nanoparticle is captured in a dark field, and as you can see, it itself consists of a huge number of atoms. This boundary marks the edge of the particle. Perhaps it's some small piece, a particle of powder, a grain of sand, or mud, or something like that. And just imagine that every object we see consists of an even greater number of objects that we do not see. And this is very interesting and truly impressive. It's also very interesting to look at such a magnificent picture. Unfortunately, it is very small. We will enlarge it now. And here, notice the arrangement of atoms marked on the electron microscope photograph. How did scientists understand that this chaos leads us to such an orderly structure of some apparently even organic substance? I don't quite know. Oh no, it's not organic. Here we actually have silicon, nitrogen, and lanthanum. Judging by what we see, we recreated the structure from the photograph. And another interesting point I want to note here is that if you don't know what to look at, it becomes uninteresting. We have now titled the video as Fantastic Images of Atoms in an Electron Microscope, because we made that understand what we are looking at. So you can also see this kind of thing. Again, spheres. There's not much interest in stopping here, but pay attention to the arrangement of these atoms. Most likely, this is some kind of deposited layer or a specially prepared sample. After all, it's quite difficult to imagine a situation where particles would spontaneously arrange themselves in such a way on a surface. Most likely, it is indeed a deposited layer. And here, it seems, we are dealing with the structure of graphene, the legendary one. The very element that is a substance. One particle thick. This is incredibly interesting because it is something thinner than even simple foil. And the properties of this graphene are absolutely phenomenal. We won't dwell on this, but graphene has an interesting feature, characterized by such an arrangement. We've mentioned this, we've mentioned that. Here I have an interesting image of how the probe of an electron microscope works. This is the very probe we described. Notice, it is a mechanical, extremely fine needle. And when we talk about scanning microscopy, we work with such a device. You see, it's very well visualized here, how the probe crawls over the surface of a prepared sample and records data. And then, based on this data, we create the images that we are looking at now. Honestly, I'm a bit confused. I can't immediately tell by eye where the transmission microscopy is and where the probe electron microscopy is. And that's why it's easy to get a little confused. And by the way, since we were talking about probes and sensors, and you've already seen the cartoon about the boy and his atom, take a look at this visualization of how an atom is moved using that very probe. And this photograph caused quite a stir, and it is notable because firstly, it won at some prestigious scientific photo exhibition, and it was taken with a DSLR camera. Honestly, I don't remember the author's name. I will provide it in the comments. But the most interesting thing is that the object in the middle is an atom, which was photographed using a DSLR camera. It was trapped in a special trap, and in this trap, it was suspended in the air. Because it was suspended in the air, it turned out like this, so to speak. To describe it, somehow, to characterize and see it. And again, you see, there it is, this sphere, there it is, this little ball, in the center of our image. And there it is, the atom that was photographed. Unfortunately, I also don't remember which atom it is exactly, but it's again a sphere, and it's again an interesting object for study.